back. I'm Kourtney Chinnery, and I'm presently a sophomore at Bridgeway Academy, and I'm in AP Calculus. This is my 7th video to my 8-part series on teaching you different concepts in calculus. Today, I'll be teaching you about limits. I'll be teaching you the definition of a limit, rules to find limits, and I'll be doing several examples on applying these rules to find limits in calculus. So, a limit is the value that a function approaches as the function approaches some value. We will be in this video discussing how to solve as x approaches infinity. And remember, you cannot divide by 0 as you pretty much can in any function. So, several rules just to help you to learn limits is that if the top exponent is less than the bottom exponent, then the limit is equivalent to 0. If the top exponent is equal to the bottom exponent, then the limit is the ratio of the coefficients. And if the top exponent is greater than the bottom exponent, then the answer is infinity. We will be discussing what this means later on in the video. And here are several examples just to teach you about those rules. So, here we go. We will be doing 3 examples. The first example is the limit as x approaches infinity of 2x cubed plus 2 over 5x cubed plus x squared minus 1. Let me fix that infinity sign. All right, so in this example, we have the limit as x approaches infinity of 2x cubed plus 2 over 5x cubed plus x squared minus 1. In this problem, as you can tell, the top exponent is 3 and the bottom exponent is 3 because that is the greatest exponent on the bottom. And by our rules, we discussed that if the top exponent, which is 3, is equivalent to the bottom exponent, which is 3, then the answer of the entire problem will be the ratio of the coefficients. So the ratio of those coefficients, is 2 over 5 because we have 2x cubed and 5x cubed, and it's 2 over 5. So our answer to that entire problem as the limit as x approaches infinity of this entire problem is 2 over 5. So that's not too bad. So for our next problem, we have the limit as x approaches infinity of 2x minus 5 over 4x squared plus 2. In this problem, our first exponent on top is 1 because it's understood 2x. The x is understood to have a power to 1. And on the bottom we have 4x squared. Our exponent is 2. So we have 1 and 2. And the top exponent is actually less than the bottom exponent. So according to our rules, if the top exponent is less than the bottom exponent, then the limit is equal to 0. So our answer to this whole entire problem of example B, the limit as x approaches infinity of 2x minus 5 over 4x squared plus 2 equals 0. So this is another one of our rules being applied. And for our last example, we have the limit as x approaches negative infinity, this time, of 15x to the 5th plus 45 over 3x squared. Our top exponent is 5 and our bottom exponent is 2. In this problem, we have, as you might have noticed, we have negative infinity instead of positive infinity, but that doesn't make a difference. So in this problem, since we have 5 on top and 2 on the bottom, 5 is greater than 2, the top exponent is greater than the bottom exponent, which gives us our answer is infinity. Well, for these rules, we have the limit as x approaches infinity. So if we have as x approaches negative infinity, the answer will be negative infinity. So on this problem, as x approaches negative infinity, of 15x to the 5th plus 45 over 3x squared. Our answer to this entire problem is negative infinity. As you can tell, if the top is greater than the bottom, then it approaches positive or negative infinity depending on the problem. So that concludes our video on limits, on teaching you the rules for positive and negative infinity using limits. I hope this video helped. Thank you for watching. Bye!